Hello everyone and welcome to Astronomy. Let's start with a simple question. Where are you in the universe? Right now you are on Earth, a planet orbiting the Sun, and the Sun itself is just one star among billions in our galaxy. And our galaxy is just one of trillions in the cosmos. So you are not only living on Earth, you are part of a vast and ancient universe. So as you begin this chapter, think about this. When you zoom out from your town to Earth, to the solar system, to the galaxy, how do you imagine your place in it all? That's the journey we are starting together. Alright, here is what we are aiming to get out from this chapter. By the end of it, you should be able to describe where Earth is in the universe, how it moves through space, and how it fits into the bigger picture. And you will also be able to think about how human history fits into the much longer timeline of the universe. We are talking about billions of years here, and it helps give you a whole new perspective. And finally, we will talk about why we study astronomy in the first place, how it helps us understand nature, and even gives us a better sense of who we are and where we come from. So this chapter is really your launch pad into exploring space and time. Now here's what we will cover in this chapter. So we will talk about where we are in the universe, when we are in its timeline, and why studying astronomy matters. And we will also go over the scientific methods, how we ask questions and find answers in science. So let's begin our journey right here on Earth. So this image shows a familiar scene, a college campus just 52 feet across. So you can easily identify objects like people, sidewalks, and trees. So this is your starting point in the universe. Now let's take a cosmic zoom expanding of our view step by step by a factor of 100 each time, traveling from a college campus all the way to the vast reaches of the universe. Now when we zoom out by 100 times, the scene now covers a full mile across. So at this scale, you can't really see people or trees anymore. They are too small. But you can make out the layout of an entire college campus, nearby streets and neighborhoods. But we are still in familiar territory. But things are already starting to look different. Now we are zoomed out to a regional view about 160 kilometers across. So at this scale, individual buildings and streets disappear. But now we can start to see the entire cities as grey patches. And natural features like rivers and mountains starts to come into view. So this image is in infrared, which means we are seeing heat instead of visible light. That's why healthy vegetation shows up in red. This is a great example of how astronomers use different types of light to reveal details that our eyes can't normally see. So now at this scale, you can see some of the natural features of Earth's surface. Now we have zoomed out far enough to see the entire Earth, about 16,000 kilometers in diameter. So from this view, our planet looks like a beautiful blue sphere floating in space. Now you can see the boundary between day and night, known as the sunset line. It's the blurriness at the right edge of the Earth image. So this line moves as Earth rotates, giving us the cycle of day and night. So it's amazing how a single image can help us understand something we experience every day. So at this zoom level, we can see the Earth and its moon from a distance of 1.6 million kilometers. So Earth is just a small blue dot, and the moon, which is about a quarter of Earth's size, even it is smaller, just a faint speck along its orbit. So they may look tiny here, but the moon is actually about 380,000 kilometers away from Earth. So these distances are so large that astronomers use scientific notation to make them easier to work with, like writing 3.8 times 10 to the power 5 instead of 380,000. Okay. Now here we see the inner part of our solar system, spanning 160 million kilometers. So the sun is a star, a glowing ball of hot gas, while the planets orbit around it. Even though the sun is about 100 times wider than Earth, from this vast distance it appears only as a tiny dot, just like the planets. So now, to make these large distances easier to handle, astronomers use a unit called the astronomical unit, AU. AU means astronomical unit. So 1 AU is the average distance from Earth to Sun. Remember, okay? 1 AU is the average distance from Earth to Sun, which is about 150 million kilometers. And we can describe other planet distances using this unit. For example, Mercury is about 0.39 astronomical unit AU from the Sun on average. Okay. Now let's enlarge the field of view again by a factor of 100. And now we can see the full planetary region of our solar system. So it's so large, about 110 astronomical units across, that Mercury, Venus and Earth are too close together to appear separate at this scale. But you can spot Mars and the outer planets more easily. And light takes only 8 minutes to reach Earth, but over 4 hours to reach Neptune. Okay everyone, ready for a space snack? Because my very educated mother just served us noodles. That's not dinner, it's the memory trick. So each word helps you remember the planets in order from the sun. My very educated mother just served us noodles. So that means Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. So the next time you are blanking on which planet comes after Mars, just picture your mom handling you a plate of noodles. Now zooming out even further, we lose the sight of the planets. So the sun is now just a point of light, and the rest of the solar system is packed into a tiny dot. So we still don't see any other stars yet. Why? Because stars are spaced so far apart, on average 30 times the width of the entire view, this entire view. Now finally we begin to see nearby stars like Proxima Centauri at a distance of about 17 light years. So 1 light year is the distance light travels in a year, about 9.5 trillion kilometers. So that's equal to 1 light year. 9.5 trillion kilometers. Can you imagine? So it's a common mistake to think a light year is time, but it's actually a unit of distance, Light year is not a time, it actually is a unit of distance. So also these dots represent star brightness, not their actual size. Now again we expand the field of view by another factor of 100. Now the field of view is now 1700 light year in diameter. So our unit changed to kilometers, to astronomical units, and to light years now. So we have now zoomed out far enough to see thousands of stars. So at this scale, the sun disappears into background. This is what our local region of galaxy looks like when we see it from far away, though no one has ever photographed it from this distance. Next, if we again expand our field of view by a factor of 100, we should be able to see our galaxy, the Milky Way. So what is our galaxy? It's the Milky Way. So it's a massive disk of stars, gas and dust about 170,000 light years across. So the sun is just one of billions of stars, sitting about 2/3 of the way from the galactic center. So the spiral arms you see here are where new stars are forming. Interesting, right? Now you can see a few of these other galaxies when you expand your field of view by another factor of 100. Here the Milky Way becomes just a tiny speck among dozens of other galaxies in our local group. So each of those small dots is a galaxy containing billions of stars and likely billions of planetary systems too. So there is a very common misconception. People often say galaxy when they mean solar system, and they sometimes confuse both terms with universe. So the truth is, the Milky Way galaxy contains our solar system plus billions of other stars and whatever planets orbit around them, or billions of planetary systems. So if you expand your field of view one more time, what can you see? So then we reach the largest known structures in the universe. Galaxies group into clusters, and those clusters connect into vast filaments and walls surrounding enormous voids. It's like a cosmic web that stretches across billions of light years. And this is the very edge or limit of what we currently know or understand about the universe. Now that you know where you are in space, let's figure out where you are in time. Now imagine the history of the entire universe stretched across a football field. One end represents today and the other end represents the beginning of the universe. It's the moment that astronomers call the Big Bang. You will learn about that in modern cosmology. So now the Big Bang kicks off the game at one end on, and the universe is approximately 14 billion years old. So the field represents 14 billion years, the entire history of the universe. And you don't even see stars until you are 3 yards in, and that's 400 million years later. And then galaxies start to form by yard 5. So our home galaxy would be one of those taking shape. And by the time you cross the 50-yard line, the universe is full of galaxies. But our own sun and earth don't show up until you are almost at the opposite 33-yard line. And that's 9 billion years after the beginning. Now let's walk forward. So life shows up around the 25-yard line, which is 3.4 billion years ago, the earliest firm evidence for life on Earth. Microscopic creatures in the oceans. And you have to walk all the way to the 3-yard line to make the life on land, which is 400 million years ago. Next, dinosaurs. They dominate the last 2 yards before the goal, and they go extinct as you pass the 1/2 yard line, which is 65 million ago. Now, what about people? We don't arrive until the final inch, which is 4 million years ago. So, what do you think about civilization? That's in the last 0.0026 inch. So, thinner than the thickness of your book page, almost 10,000 years ago. Every empire, invention, and buildings, all crammed into that tiny line. So we are incredibly new guests in a very, very old universe. So this whole course revolves around two big questions. What are we and how do we know? Now, who are we? That's more for literature or philosophy. So here we are talking about what you are made of. And the answer is wild. The atoms in your body were created in the Big Bang or cooked inside stars. So you are literally part of the universe's 14 billion years story. Very interesting, right? But it is not just about knowing things. It's about how we know. That's where science comes in. So in this class, we will use astronomy as a way to understand the scientific process, how we gather evidence, test ideas, and build real knowledge. So in science, we don't just collect facts, we figure out how we know them. The scientific method helps us test ideas with evidence, but it's not a strict formula. So that's a skill you can take far beyond this class, especially when navigating a world full of claims, opinions, and decisions. Now that's the end of chapter 1. So this is the summary of chapter 1. So in the first section, we learned about where are we in the universe. So where are we? You are living on a tiny planet that orbits an average star in one galaxy out of billions. Earth spins every day and orbits the sun every year. That's what gives us day and night and our seasons. Next, we learned about when is now. And in time, we are incredibly new. The universe is 14 billion years old, but humans have only existed for a few million years. Civilizations? Just a blink ago. Barely a silver of cosmic time. So we are newcomers to a very ancient story. Next, why do we study astronomy? So astronomy might seem like it's about stars and planets, but it's really about you. It tells you where your atoms came from and how you are part of the cosmic story. But it also teaches you how to think scientifically. How do we know any of this? That's where science comes in. Testing ideas, observing, and using evidence. That mindset helps you in way more than astronomy. It's a life skill. So that concludes chapter 1. So now you can go over the practice questions and then complete homework 1.